Hi everyone, today we're going to show you how the Alpha Chi Sigma Pledge class put on America's Got Science at a local retirement home in San Luis Obispo. We organized a talent show structured chemistry showcase. This video will go through each reaction that was done.
I'm David.
I'm Adam.
And I'm Kara.
And I am one of your hosts for this evening. And as a proud Pledge class president, it is my honor to welcome you to America's Got Science.
This is our baking soda and vinegar balloon reaction.
Okay, so here's the science behind it. It's an acid-base reaction, with vinegar taking on the role of the acid, and baking soda taking the role of the base.
Next, our secret ingredient are these balloons. And while they don't look like much, they already have baking soda in them.
The balloon is flipped upright, the vinegar and the baking soda react to form carbon dioxide. That's the bubbling. This gas moves up the water bottle because it has nowhere to go and causes the balloon to expand. This balloon expands not into the balloon, not the water bottle, because the balloon is stretching and change its volume, unlike the water bottle, which is stiff. This is used to blow up the balloon.
Next, we're going to talk about the elephant toothpaste reaction.
Hey guys, Robert here, part of the elephant toothpaste experiment. So first of all, we're going to measure out some 30% hydrogen peroxide. We're going to be putting this into the graduated cylinders after measuring it out. And now we're going to be mixing it with soap, right? And then we're going to be putting some cool colors on it to make it look like the toothpaste that elephants could use.
So what's your magic ingredient?
Right now we're putting
food coloring.
Just to make it pretty.
So now we're going to be mixing the Ki, our catalyst, and now we add it in.
Now we'll show you the iodine clock reaction.
It's a reaction that you should watch very closely, because in this reaction, it's blink and you'll miss it.
So we have heated water here. This water is already warm. I'm going to add an extract made by crushing up vitamin C pills and filtering them through coffee paper. So I'm going to add this to 1 solution of hot water. Get a little swirl. And then I'm also going to add 12 milliliters of iodine. So this is something like if you get a wound and you go to the emergency room, they might rub this on your wound. So this is an inert form of iodine. Other forms of iodine, like one that will be produced in this reaction, can be more toxic. That will be quickly reacted, so there is no danger. So here we have 200 milligrams of starch. We are going to add boiling water, up to 40 milliliters. And then we are going to add 100 milliliters of hydrogen peroxide.
3%.
And this is 3% hydrogen peroxide, this is not 30%.
This is the one you get from the store.
Alright, so now we are going to mix both these solutions into the bigger beaker. You can go ahead and pour. And in the meantime, Adam, why don't you tell a joke? Because this might take a second. But
We're on the topic of science today, and we gotta make these jokes science related. It just takes me back to this other day. I took a 23andMe. We all know what that's about. It tells you about your family history and whatever runs in your genes. As you can see right here, I got these glasses. Eyesight doesn't really run well in the genes. But actually, there's this other thing that had me absolutely flabbergasted. It turns out that diarrhea runs down your genes.
Oh! There it goes!
What the fuck just happened here? Well, let's go down a little scientific path. Iodine has 2 different forms, in its inert form and its reactive form. It usually likes to react with starch, and when it reacts with starch, it turns into this lovely dark blue color here. But the thing is, we interrupt that reaction by introducing vitamin C. And when vitamin C and the iodine cha-cha, they like to make a translucent experiment. But all these factors compound, so the clock just ticks away until the iodine has a chance to react with the starch. And like I said, in this blink and you'll miss it, it turned dark blue in like an instant.
This is the lava lamp reaction.
So me and my group did the lava lamp project, which was pretty cool. It's a really simple experiment, chemically wise.
Today, our reaction just uses 3 simple ingredients. We have water, vegetable oil, Alka-Seltzer, and food coloring for color.
So we have 3 colors here, pink, green, and blue. Does anybody have any suggestions for what color we should make our lava lamp today? Green. Green? Good choice. All right, so we're gonna add that to the water real quick.
You've got water on the bottom, and then we have a bigger, large amount of layer of vegetable oil. And obviously, like with polarity, they don't mix, so you have distinct layers, and then the oil is less dense than water, so it's on top. So we put in the Alka-Seltzer tablets, which produce the carbonation. So once we drop the tablets in, they sunk to the bottom, and then the gas rose up to the top and went through the oil, creating like distinct bubbles colored by the food coloring. So super cool. The people loved it, and yeah.
This is how we made Alka-Seltzer rockets.
Okay, so for the Alka-Seltzer rocket experiment, basically we filled up these little like foam canisters halfway up with water, and we put Alka-Seltzer, like a quarter of an Alka-Seltzer tablet in them. And what that did is the Alka-Seltzer reacted with the water, started dissolving, which created carbon dioxide. And so when we capped it, it would build pressure, and eventually it would just blow up like a rocket.
Now we'll show you the cabbage indicator.
So we did the red cabbage indicator experiment, and that involved us taking red cabbage that you just get from the grocery store and boiling it down and extracting the water. And in this water contains a chemical called anthocyanin that's present in red cabbage, and it works as a natural pH indicator. For our experiment, we chose a wide selection of a couple different acids and a couple different bases. We had bleach and sodium bicarbonate or baking soda for our basic solutions. For our acidic solutions, we had vinegar and Sprite, and in the middle we just had a cup of water. And so when you combine the red cabbage indicator solution with all of our different acid and base solutions, you get a different color based off of the anthocyanin reacting with the acid or base that's present in the compound. And as a result, we had a wide array of different colors, and it was very exciting to see the basic solutions turn more green and blue, and the acidic solutions turning more pink and red.
Last but not least, we'll show you how to make slime.
So hello, my name is Nick, and the experiment that we did today with my group was the slime experiment. So slime is a mix of borax and glue, mainly. That's what it is. And glue has a molecule in it called polyvinyl alcohol molecules. And normally they're just able to kind of slide around and mingle as like liquid does, right? So it's form changing. But with the mix of the borax kind of cross-links with molecules in the glue and cause it to firm up into something that's all slimy and gooey. And that was our experiment. It's fun, safe, and you have a little stress ball after.
Unfortunately, that's all the time we have for today. So, in a concluding send-off, may we please congratulate, and say with me now, America's Got Science!
That concludes the reactions we did for America's Got Science. Thank you for watching.